Good morning, everybody. I'm going to be talking about Kayenta Automated Canary Analysis. If you're on the wrong flight, please check with your stewards. My name is Michael GRAFF, and I'm a software engineer here at Netflix. This is Matt DUFTLER, who is a software engineer at Google, and we've been working on this project called Kayenta, which is a rewrite of stuff that we've been doing at Netflix for quite some time. But it's in a, we intend to open source this one. It's written in a modular way, and it's tightly integrated with Spinnaker. We're going to be talking a little bit about canaries in general. We're going to be talking about the internals of Kayenta, and then we're going to give a demo of where we are right now with the UI within Spinnaker. There was a talk yesterday with Chris and Greg about what canaries were, but I kind of want to cover the key points here just in case anybody missed that, since this is a 3-track conference now. Canaries operate on live traffic. They only get a part of that live traffic typically, so that the impact is minimalized. The main purpose for a canary is to make certain that you can roll stuff out into production in a gradual way to make certain that your code is good or your operational change is good. Typically, it's going to be talking about code deployment because that's what Spinnaker particularly focuses on right now. But it could be any operational change. It could be a network change or anything that you want canary. And it's not a replacement for standard testing. So that's something we want to keep emphasizing. This is production-ready code that you want to canary. This is the typical pattern that we use at Netflix, although sometimes the baseline is omitted and the production is used as a baseline. The green parts here, the baseline and the canary green parts are handled by Spinnaker itself, where it spins those clusters up. The part we're going to be talking about is on the right-hand side, the canary analysis, which is the Kayenta modular part. This is the flow of what Kayenta actually will do. It starts out in, there's basically two parts to Kayenta, two main parts to Kayenta. One is the gathering of the metrics and then grouping them in such a way that a judge can then use that very, very easily. For example, when you query for CPU on the baseline of the canary, we present those to the judge internally as one unit so that the judge can very easily determine what that is, and there doesn't have to be a lot of intelligence on the judge to order the data. It just uses what's there. The judge itself is responsible for doing data cleaning, metric comparison, and then finally computing a final score. And how that's actually done, I'll go into a little bit of detail, but not very much because it's kind of beyond the scope of this chat. This is more of an overview. The Netflix judge, which is the one we've implemented right now, scores each metric as either a high, low, pass, or no data. And in some cases, high and low are okay. You know, if your canary is performing better in terms of CPU usage or better in terms of requests per second, that's probably okay. So there are ways to control which direction we compare. We then assign those are assigned to groups by the configuration, by the person who's doing the configuration. Those groups are scored independently, and one metric could be in multiple groups. A weight is applied, so you can say that this group has more importance than that, and then at the end, a final score is calculated, and then that's compared against the threshold. And that's really what Spinnaker is going to look at in the main dashboard is, did this pass, did this fail? It's a single number. So the goals of this project were to take a system that we already have at Netflix and bring it out into the public, and to make it more modular, make it so that it would be extensible. Our old system was written and grew organically. And because of that organic growth, we never really had easy ways to insert new data sources. It was very tightly integrated with the judge component. The data marshaling internally was not very clean. It worked, but it was very difficult to add new data sources and very difficult to add a new judge. The new model actually allows those to be plug and play pretty much across the board. And we do that with some internal APIs that Matt will go over. But really, we found that most of our users, when we started with Canary Analysis in Netflix, most of our users did not use Spinnaker because Spinnaker wasn't really as popular as it is now. Now, almost all of our users that use Canary, not all, but almost all, actually use Spinnaker. So it made more sense to tightly integrate with Spinnaker and the workflow that people use commonly. It can still be used outside of Spinnaker. There's still an API that you can call. So it's not like the system is completely integrated within Spinnaker, but it's still a module off the side, but it looks really nice internally. And we want to open source this because we think that it will serve the Spinnaker community as well as us to do so. The technical goals are pretty straightforward. We want to make it faster, better, meaner, stronger. And one of the important things we're doing here is along the way, each step that we do is written to stable store. So when we gather metrics, those are written out to an S3 bucket or something similar. When we actually combine those into the next stage for the judge, those are written out to S3 again. And the result of that judge is that will be written to S3. Currently it's not, but it will be. And the purpose in doing that is it means we can inject data at any particular point in the system. So if you have data that isn't really in a database, you just want to run it against the system, you can write it out in this format, and we can still run the judge on it. We don't actually have to fetch it from various data stores, like an Atlas or whatever. And with that, I'm going to hand it off to Matt.
Thanks, Michael. All right, give me a second here to. That legible? All right. So the purpose of this portion is to show you the thing working. We'll be as transparent as we can about the state of things, what's to come next, how long we think it'll take, what we're missing, what we did a good job of, all of that. If you have questions, shout them out. One thing we realized in preparing for this is that it's hard to kind of show the thing working all the way through and keep referencing various formats and tools and components without actually explaining those things. So we're going to uncharacteristically start kind of down in the weeds and quickly just touch on each format and each component just so it looks familiar when we show everything working kind of all the way through with all the plumbing connected. It's a new microservice. So as far as Spinnaker concerned, it's a top level thing like Orca, like Front 50, like Clouddriver. What this means concretely is that Halyard will have full support for configuring it. It'll have health checks. It'll have all the things that make it a part of the Spinnaker ecosystem when it's deployed as part of Spinnaker. If you folks went to Rob Fletcher's excellent talk on Orca v3, we're heavily leveraging that here. So Kayenta is using Orca to do its work. So it links in Orca as a library. It doesn't call out to it. You use the queue-based messaging system within Orca to schedule work. So it's stateless, it's resilient, it can be horizontally scaled, all of those great things that you get from the new version of Orca. Kayenta basically leverages that directly. It's entirely pluggable. So it works with multiple telemetry systems, multiple storage systems. So S3, GCS, we have in-memory implementations of a storage service for development, and the judges are pluggable as well. The paved road out of the box experience is the Netflix ACA judge with all the years of experience that went into that Chris and Greg presented on yesterday. So all that sort of goodness is in here out of the box. And one nice thing about the way we built the system is, we got to kind of take all the existing stuff that's been learned by Netflix, combine it with some stuff that we know about building systems, especially out in the open source community, and come up with something that's very composable and dynamic. And it supports doing both real time, meaning you're waiting for the canaries to gather data and complete, as well as retrospective analysis. And they feel basically the same. You can do quite a bit of kind of looking back and what if scenarios without too much handwork. So, and we're going to show all that now. So we'll start with the most boring part, the Canary config. We'll go through it quickly. The main thing to take away from this is that this is metric store specific. So if you're working with Stackdriver, Atlas, Prometheus, there are a bunch of systems like that we intend to support. This is the bit that looks specific to that system. The rest of it is quite generic. So defines a query. And with some systems, it looks like a query. Other systems, it looks like just the name of a metric that's going to be queried for. But you're essentially defining a parameterized query. To actually execute that thing, it has to be hydrated with various scopes and parameters that come in at runtime, which we'll show. But that's the idea. Metric store specific query is defined within the Canary config. As Michael explained, works with a bunch of different metrics, and all those metrics that are yielded by that metric store specific query get grouped. And this is done by the application or service owner. And then each of those groups can be weighted and scores are rolled up and all the stuff that Chris described yesterday, which we'll show in action, but not get into the low-level details of. So these are the high-level attributes of a Canary config. There really isn't anything that surprising in there. It has a name. It has timestamps when it was created, when it was touched. There's some versioning stuff. There's a human-readable description. There's some metrics which are collapsed, which we'll show in the next slides. And then there's the weights we talked about. the goal of all this stuff is some automated gating function, right? It does all the analysis, it comes up with some score, and then you want to compare that to some thresholds you've defined and say, is it marginal? Did it pass? Should I fail right away? So you have to specify those thresholds as well. And that's what you see on this slide here. So here we're just giving equal weight to the two different groups, system and disk. The metrics defined within there are hidden at the moment, and then we define the threshold, which we'll go into more detail on. So this is an example of one particular metric. This is against Stackdriver. In this case, if you look at metric type, it's just the name of a particular metric exported by Stackdriver. We put it in a system group, which is just it's like a logical grouping. That name doesn't, at the moment, have any inherent significance. And then we say what judge to use. And all this configuration is passed throughout the various stages of the canary. So I'll flip back and forth a little bit. So as I go through back and forth between these two slides, they look basically the same. It's just referring to two different metrics, both Stackdriver defined. One is CPU, one is disk write ops. I put them in two separate groups. No other difference there. But here's where it gets kind of interesting. This is an Atlas metric. So remember, this is in the Canary config. So obviously we're specifying a different system. Forget about what group, we went back to saying system. But in this case, instead of referring to a metric type by name, it's an actual query. So that's it. I mean, that's what's in the Canary config. Obviously, you're typically dealing with many metrics. In this case, we kept it as small and simple as possible so that it's legible on the slide. And here's another Atlas one. Same thing, two different queries, different group, same backing system. All right, in terms of how we support these configs, there's full support in Spinnaker programmatically for publishing them, querying them, deleting them, updating them, everything you'd expect. There is UI support embedded within Deck itself. The intent is that users won't have to switch from this tool to that, from this environment to that, to edit their Canary configs, to configure their pipelines, to interact with the executed canaries and dig down to the results. The idea is that all of that would be contained within the UI. And we'll call out throughout this state of these things. So the state of the GUI editor for the Canary configs is it's almost there. It's mostly usable, but not quite there. So these are the renderings from Jeremy here, Tatelman. So it looks a little better than the editor, which we're going to show in a second. Sorry, Dan and Scott. But it's a little bit further along. We're going to show the editor in a moment. But it looks very slick. This is the goal, is to get to this end state, to have like a very polished experience that feels like the rest of Spinnaker, but brings in all of the Canary stuff. Okay. All right, so that's the editor. And then the idea is that somebody manages or curates those Canary configs. Maybe it's the application or service owners. Maybe it's some group within your organization that has the expertise to say, this is kind of the paved road, at least start from this and then customize it for your needs. But the idea is that you build up a library of those Canary configs. And then in your pipeline, when you say, I want a Canary stage here, you just pull from one of those, you pull one of the choices from that library of Canary configs via a pull down. And all of that works, and we'll show you. All right. We defined a Canary config. We're going to execute this thing at runtime by hydrating it with some information. And then it's going to reach out and call some backing metric service and get back some results. And those results are going to be in a format specific to that service. Prometheus results look different from Atlas, look different from Stackdriver, look different from OpsMx. These are all going to return slightly different results. To integrate with a backing telemetry system, you have to implement this small component, which is a metric service. And that metric service is responsible for yielding this common format. So it makes its calls, does whatever validation it's going to do, and then it transforms it into this common format. So the end result of any of those metric service implementations is going to be data that looks like this. So there's a name for that metric. There's some tags, key value pairs that uniquely identify it, some timing information, step size, and then the time series data itself. And if you have questions, just shout them out. So far, this should be fairly straightforward. One thing we want to make clear is we want to build a community around this. We want people to add support for additional systems, and we also want our lives to not be hard. So we put quite a bit of effort into making this thing easy to work with. So all of the underlying bits are exposed via entry points. It's all swaggered. We spend a lot of time when we're working with it, working with the Swagger UI. It's very easy to capture data, post it, rerun analysis, and try to reproduce just the steps you need, not have to run full Canary pipelines. So there's a bunch, but everything from the CRUD operations for the Canary configs themselves, stuff to say what judges are configured, kick off actual Canary pipelines, what buckets can I reach, what metric services have accounts configured, everything's there. So we mentioned Kayenta relies on Orca to do its work. So what Kayenta, which is the Canary service, is doing under the covers is running a pipeline. It's not the top-level Spinnaker pipeline. It's not your application pipeline. It's a pipeline that's doing the work of a particular Canary run. And it looks roughly like this. So you have two stages that happen in parallel. One is fetching data and converting it to that common format for the baseline. One is doing the same for the Canary. So these happen in parallel. They join together at a step that essentially pairs them up. So make sure the start times align, make sure you have the same number, similar number of data points. It tries to pair up the tags, the key value sets have to match, and then it produces one common format with all that data paired up. And then the last step is to perform the analysis and report the results. So all that work is scheduled by Kayenta via Orca. So it can happen on multiple Kayenta instances. You don't need any sort of affinity to get back to the same instance. It just goes off and happily does its work. There's an entry point that says, do this Canary run for me. And you give it the parameters that are required, which we'll look at in a second. But you can kind of mix and match these stages and do whatever makes sense because they are proper Orca stages under the covers. You can send a custom pipeline to Kayenta and say, do this, and it'll do it. And that's how we do quite a bit of development and troubleshooting. So what this looks like in practice, you want to kick off a Canary pipeline. So Kayenta is going to do a particular Canary run for your parent Spinnaker application pipeline. So you have to reference a config. So one of the JSON format files we looked at the beginning, you have to give it a scope. So this server group or this cluster or this host, the most common path is it's a server group, some group of replicas. And then you give it time boundaries. So you're saying, consult this Canary config that exists in the Canary config library, apply it to this particular server group, meaning hydrate it with this parameter required by the custom query, and do it within these time boundaries, this step size, all those kinds of details. And you do this for the baseline, you do it for the Canary, it goes off and does its work. So it makes a call to the backing metric service, whether it's Stackdriver, Atlas, Prometheus, whichever service it happens to be calling, and then it has to transform it to that common format we looked at. And that format ends up, whether you have a GCS or S3 configured, you can do development locally, it'll just end up in memory, and so on. The nice thing about this approach of persisting things at each step is all this stuff can go away and you haven't lost anything. Besides that, the Canary pipeline itself can carry on. You can just refer to those things later. Just grab the ID out of the pipeline status, and you can pick up. Yes?
Persistence from 50 or?
It's not through front 50, although the code looks suspiciously similar to what's in front 50.
Is there a reason for that?
Not a technical reason. I mean, it's like one of the goals with all this work was that we tried to not impede any sort of work for the internal Canary system or impede work for front 50 and the other Spinnaker projects. We tried to kind of move fast by doing it in isolation with the goal to eventually converge back on a common library. And that work is kind of underway now to pull out of front 50 the work that does all the storage work and then make it a library dependency of each. So right now we would have either had to make remote calls to front 50 or try to link in modules of front 50. So we essentially copied over and cleaned up a bit, a couple hundred lines of front 50 code. So not a very satisfying answer, but that's the size of it. All right, so merge metrics, match up the different sets that have matching key value pairs in the tags maps. Make sure all the start time is the same, step size is the same, correct number of data points, produce one thing. That common format looks just like the original common format, only now there are two things. So instead of, I'll find it. So imagine this thing, but instead of just values, it has baseline and then a set of values and then Canary and a set of values. It looks very, very similar to this. It just pairs up the result. So that's done by another worker stage within Kayenta. Again, that gets persisted. And then the last step is to perform the analysis. And kind of funny, Michael touched on this, but as we were putting this together, Michael pointed out that I forgot to put the fancy file folder thing at the end of Canary analysis here. And then it turns out I didn't forget to put it on the slide. I forgot to put it in the code base. So it does return the results, but it turns out they only live at the moment, hopefully until later today, in the pipeline context, both of the parent. So this is sort of like a form of unit testing, and we verified that we forgot to do that. All right, so in terms of how this works with Spinnaker, and we're getting to the fun part in a second, there's a new Canary stage. we touched on this a little bit, but the idea was to leverage as much as possible the existing Canary and ACA stages that live internal to Netflix, and I know the OpsMx folks have sort of re-enabled those against their system as well, but they're not heavily used. They live mostly inside of Netflix. We wanted to leverage it as much as we can, but not directly reuse it, because that system has to continue to live on while this system is developed. And we'll get to this, I think, in a little bit, but the goal of this thing is to get it to a point of maturity such that Netflix and Google feel comfortable sort of foisting it on the public and saying, here's how we think you should do things. So to do that, we kind of have to like the canary system and run it internally here and with some other customers to make sure it does what we want, especially with respect to the behavior of existing systems that it'll eventually squash out of existence. Right? It's going to be like every other Spinnaker server. So there's full API and GUI support for everything we're going to see. Configuring the Canary configs themselves, so specifying them, editing them, is full UI support and API support. The Canary stage within the pipeline editor. So your application, you want a Canary stage, there's a full UI for that. And eventually to drill down to the Canary reports. There are renderings for that kind of thing, but there's no work at all on that yet. The score is surfaced, but there's no drilling down yet. So that's hopefully soon, but definitely in the future work. All right. So since we don't want to wait hours for things to complete, I ran a bunch of things in advance and we'll poke around and we can change some things real time as well. But it should look moderately familiar. This is Spinnaker. There's a new tab, this Canary tab up there. Now, I should say where this work is taking place. There's a still private GitHub repo for Kayenta itself, and a still private, like called a layer on top of a deck Kayenta repo where we have this additional work. But that's basically it. So I think I'm running this deck instance locally on my laptop, and Kayenta is running on a VM that has all the rest of Spinnaker. But the updated UI has a Canary tab. So you click on this tab, and you'll notice it looks exactly like the renderings. Well, it's getting there. It's pretty cool. So Dan from Google and Scott from Netflix have been building this out, and they're using Jeremy's renderings, and it's pretty cool to see it come together. The idea is you define a config this way. So there's a full editor. The format that's behind this is the first format we showed, so the name, the description, and all that. But this is where you define what metrics you care about. You say what system to make those, to execute those calls against, how to group them, and eventually how to weight them, and all of those things will be defined in this UI. It's nice, depending on the system, it's going to have some specific bits. So if it's Stackdriver and the metrics are configured differently than Atlas, those UIs will look slightly different. But in keeping with most things Spinnaker, it's backed by JSON. There's an editor. You can bring it up, edit the JSON directly. Those changes are persisted. So even the things that aren't supported in the UI yet, you can still get to.
Can you zoom that a little bit for?
Sorry, Steven, I didn't know you were here. Is that better?
Yeah, that's good.
So, but this should look a lot like what you saw on the first slide. So, the classifiers, so the weights and the groups and all that, timestamps, description, and then all the different metrics. So I think there are 4 metrics. Okay. Can I go back to the size, Steven? You good?
Yeah, thanks.
Okay. So that's a config. Now, when we get to a pipeline, so this is a very simple pipeline we configured, but pretty true to life. So there's a bake stage, there's a deploy stage, there's a canary stage. So the bake stage is what it is anywhere. Deploy. We're just deploying a new server group. There's one cluster running in this application. There are a few server groups within it. We're going to take the sort of second path Michael described. We're not going to provision a baseline and a canary. We're just provisioning a canary, and we're using the existing production server group as the baseline. And we did this in advance, but I'll show the details. So there's server groups 5, 6, and 7. So we'll look for those in the execution details. But looking at this pipeline, you have bake, you have deploy, you have canary. Nothing too exciting here. No surprises. It goes into that cluster. I think I added into the startup script to generate some artificial CPU load, and I was able to turn it on and off to cause it to fail or fast. But other than that, there's no magic. But here's the new canary stage configuration. So the top is the typical control flow editor, and then you have the config itself. Okay, I can make that. Good, Stephen? All right. So we have the analysis type, so real-time or retrospective. I think a real-time is I kick this thing off, it says, wait 20 minutes for things to warm up, and then run a 2-hour canary at 30-minute interval. That's the kind of information you would give to a real-time configuration. And you see that information here. So there's lifetime and hours. There's result strategy, which we'll explain in a second. This is the pull down that lets you choose from the library of configs. I only have one in there, so that's what you end up with. 5-minute warm-up period, 15-minute intervals. So you're going to end up with 4 canary runs, starting at sort of T plus 5 minutes and running to T plus 65 minutes. And then the analysis type, growing or sliding look back. So growing is always start at the beginning of when you started collecting the data and run up until the point you ran the canary run, and sliding look back is just from now, go back however many minutes the interval is. Actually, I think you can say how far to go back. That's not right. Yeah, you can say how far to go. All right, so this gets a little interesting. So these are expressions. They're hard. Nobody can get them right. I had to ask Petriel from Waze to send me the expressions that work for them with their internal system, because I know we worked on them and they do what we want to find baseline and canary groups. So it's funny, but the real story here is that we need to come up with helper functions and provide them there, where you can say, like, get me the latest or get me the newest or the largest or whatever from this cluster, and give some, like we do targeting coordinates and all the other stages. We need to have helper functions for that, because this thing where you sort of like run a pipeline, capture an execution trace, and then just like add one leaf at a time and hopefully try to land on the right value with your expression is kind of painful. So that's why you end up with giant expressions like this. So we'll make that easier. In the meantime, what these two expressions do is resolve the last server group running in that cluster before we ran the pipeline, and then the new one that was provisioned by the upstream deploy. So we end up with those 2 server groups as values. We'll leave the default step size, which I think is a minute. The threshold is kind of interesting. You saw we specified those in the Canary config. So it just uses those values as the defaults for the UI, and you can configure whatever you want and override it, which makes it easier to do like retrospective analysis, where you start moving knobs and sliders around to land on the result you want. Last thing, it's a standard Spinnaker stage, so you can send notifications and do all the things you can do with other stages. Yes?
Is there going to be a separate canary configuration for being able to clean up baseline and canary?
Yeah, this is a great question. So Tomas's question was, some folks might not have heard, would there be a separate configuration to also be able to clean up the baseline and canary, like the infrastructure that's provisioned part of this? So the current story in Spinnaker, there are 2 stages that relate to canary. There's a canary stage and an ACA stage. So canary stage provisions a baseline and canary. And as you remember from Chris and Greg's talk on canary systems yesterday, the idea is that they start at the same point in time. One hasn't, had a longer lifespan and start taking on different behaviors. You want them to come into existence at the same point in time, so you're comparing apples to apples and not disturbing your production infrastructure as well. So that's the canary stage. And then over time, eventually an ACA stage was created, which just does the canary bit. So it assumes that the infrastructure exists, and you just refer to those 2 server groups or clusters or whatever to do the comparison. What we've done so far is more closely approximates the ACA stage. So that's why we have these expressions. We assume that infrastructure exists, whether because of something upstream in this pipeline or because of something else. We neither provision nor clean up infrastructure. It has become clear that we're going to have to do that as well. We just haven't done it yet. In a moment, we'll show how this thing actually does its work, and we think it'll be in like an almost trivial amount of work to also synthesize those stages. But we haven't done it yet, but the answer is yeah, we're probably gonna have to do it. Yes?
The configs, are those restricted to this particular application, or are you able to like share configuration?
I don't think they are. Dan, do you know the answer to that?
They're restricted applications.
Yeah, there's just a list of canary configs, and it gives you everything. We don't, and I don't think we have a search API on there yet either. So it's pretty much giving you anything that's returned by the backing Kayenta instance. Yeah. Yes.
Forgive me for being ignorant, but I'm just wondering, how are you aggregating these logs of these metrics from third parties, like let's say hosted GRAFF or some other thing, and then how does that provide the hook to write to wherever area you're writing so they can be consumed by the metrics?
Sure. So the question was, I think, how are we collecting the logs from the backing systems, and then how are we persisting them?
Like you have to be able to put it somewhere for this analysis to be occur, like
okay.
Where's the hooks in to make sure that those metrics from third parties that are not immediate?
Okay. Yep. So Kayenta nor Spinnaker is responsible for making sure that the applications can publish metrics to those systems. So before you can use a system like this, your application has to be capable of publishing the metrics, and you have to have some way to consume them. And the Kayenta service that backs this gets configured with credentials to consume those services. So in the case of Atlas, it's not really credentials-based. You protect access to it, but we don't have to give any kind of key to access it. You have to be able to reach it. In the case of Stackdriver, you have to give a JSON key associated with a service account to the particular Kayenta instance to be able to consume those metrics. But it's not Kayenta that's closing that loop. You have to be able to publish the metrics, and you have to be able to provide a key somehow to consume them. And there are, custom integrations with those backing systems in Kayenta. So Kayenta has a module for Atlas, a module for Stackdriver, and a module for Prometheus so far. Does that make sense? Okay. All right, so this is a fairly simple, let's call it a real-time analysis, and we ran this ahead of time. So looking at the executions, we ran one that succeeded and then one that we caused to fail. So there's a bake, nothing too exciting there. And then we had a deploy stage, and it provisioned group V006, and then the canary executed. And here's where it gets kind of interesting. So we said, I think 1 hour, 15-minute intervals, and give it 5 minutes to warm up, I think, I hope. Yeah, so here's the configuration. So there's the config that was referenced, the type of analysis, and the other parameters we just mentioned. And you can see what those expressions evaluated to it resolved group 005 and 006. So the baseline was 5, canary was 6. But here's where it gets kind of neat. So what the new canary stage in Orca is doing is synthesizing stages to do this work. So it does a bit of arithmetic based on the timing information, and it says, well, you want to wait 5 minutes. Orca knows how to wait. Why should I wait? It just synthesizes a wait stage. Then it says, okay, then we have 15-minute intervals. So 15-minute wait stage, and then we have a run canary task. And that run canary task, you can see run canary 1, 2, 3, and 4. Those are the calls out to Kayenta. The rest of this stuff is happening within sort of Orca proper within Spinnaker. So if we take a look at the actual results, so in this case, things are grand. Everything came up 100. And if you take a look at the durations, you see 15, 30, 45, and 1 hour. And this might be a little hard to read, but you can see the updates, you can see the durations, you can see the results. Okay. So if we take, yes?
This might be knitting on it. Why does it take over a minute to return a?
This is an awesome question, actually. So there's a kind of, I think I saw Rob Fletcher walk in. I see him leaning forward. Do you want me to start and then you correct me?
Sure.
All right. So if we look at this, I did not ask him to ask that question. But so these two things are stages that happen in parallel, and then there's a join. And the way the Cubase stuff works, when that's one stage really, this sort of fetch and transform. When that stage completes, it says, I know I have downstream stages. Let me emit a start stage message or an event. So I'll push a start stage message from merge metrics. And then merge metrics basically gets out and says, I still have upstream dependencies. Let me wait a minute, see if they're satisfied. And then this one here pushes its message at almost the same time, but not the same time. And then it says that's an identical message, and it ignores that one. And then you just have to wait for that interval. Is that a working? All right. So that's basically it. So we can make that configurable. We could make it different, but
the plan is to fix that so that right now, if what looks like a duplicate message is coming into the queue, it just ignores it. Whereas what it should do is like preempt it and move the.
Yeah, prioritize that one to say.
Any particular reason for 60 seconds? I'm just curious what it was. Just a starting point.
So the downside is we wait a minute on the canary and it's like 3 or 4 seconds of work, which you'll see in a second. The upside is we saved like 3 years of work by just leaning directly on Orca. So we sharded out that time to everybody in the future. So yeah, but that's the idea. But it's a good spot. And yeah, so that was the one that succeeded, which was the earlier one. And then here's one that failed. So if we look at the configuration, you see the tasks are basically the same. It waits its 5 minutes, wait that initial interval, kick off that child canary run. And it failed. And then you look here and you see, okay, here's the result. It's a failure. It gives you a reason. And all that's rolled up from the underlying judge. And then you can see the timing information. We did some, and I suggested it. I didn't do any of it. But we have a clipboard thing, so you can copy and paste the ISO timestamps that underlie that canary run. The idea being that it would be very nice to be able to quickly say, well, it didn't quite do what I wanted, but I feel like I'm close. let me create another pipeline with that canary stage and start to play around with it. And then we did a bit of that earlier in preparation for this. So that was a real-time canary run, 15-minute intervals over an hour. So here's a retrospective canary run over the same server groups with the same intervals, but no waiting except for the minute. So retrospective instead of real time, and the parameters are slightly different. So instead of warm up time and that kind of thing, you just give the interval, and the rest is basically the same. You have baseline and canary, but then just below that, you have start time and end time. And we copy pasted those values into here. So it's the same infrastructure, the same parameters, same canary config, only we don't have to wait for anything to happen. We can run it real time. You can set different thresholds, all of that you can change. When you run this thing, take a look at the execution. So if you look at the tasks that were synthesized, there are no wait stages because we don't need them. The timing values would all line up. See the parameters here, and then you get the end results. So this matches the initial successful one, same exact results. One thing you'll notice here, so we're not waiting a minute, we're waiting 4 minutes. And there's actually no reason to do this sequentially. We can certainly do the runs in parallel. We probably should. It seemed easier to consume this way, but we can just render them that way. We don't really have to do them sequentially. So, but those are essentially the same runs. The different data is persisted at each step. It doesn't squash any of the existing results, but yes, Tomas.
It's not very clear to me. So the Canary engine then, for you to like always persist the information for the metrics in the data source, or like I can retrospectively look at it, or does it have to be something that I specify here?
I missed the tail end of it, but it's just what you spend. Just the results of that hydrated query are persistent. It's not only those systems. It makes the call when it needs to and persist the results in the common format.
So you could actually just have like that start and end time as parameters, having never run the canary.
That's what I do most of the time. That's exactly what we do most of the time.
Yes, this will, even if you specify the same start and end time as before, it will query again currently, but there's no reason we couldn't make it later to reuse the same data from the previous. That's correct.
Yeah, we do that constantly. It doesn't even have to be stuff that we've had any interaction with Spinnaker before. We're just querying the backing systems, collecting some data, and then you can run sort of smaller versions of that canned canary pipeline and say, I don't even want you to do the queries. You can easily post to one of the development entry points, here's my common format, and you can tweak it by hand, which we do, make sure things are doing what we expect, and then execute that with Village as well.
To allow you
I'm sorry.
Are there plan to allow you when you're configuring the canary, since you already have this data, to just say run this to timestamp and do it by run?
It's on the this would be a great idea slide. Yeah. Just didn't get to it, but absolutely. I think I saw another hand. Yes.
So I think it's the result strategy is lowest or highest. Is that right?
Yes.
So I had a so one thing, I think I'm missing something because, lowest and average, okay. So one of the things I was wondering is whether you could use like marginal versus pass is either going to go, one's going to be smaller or bigger than the other, and so you can infer something.
Yeah,
like that.
this goes to something we haven't really dealt with yet that Chris talked about in detail yesterday. That is something I think we're just getting to now, which is this idea of having different types of metrics where you could say this is an error metric. So we could sort of implicitly know that, well, less is okay too. So instead of having to specify those kinds of rules or qualifiers for each metric, they would have some identifying characteristic or attribute where we would know certain things. So in this result strategy actually has to do with if you're running, if you're collecting data from a bunch of different regions and then running local analyses in those regions, how to aggregate those. So maybe it's a wrong place to surface it, or maybe a little higher level.
Just to point out, though, the result strategy is specific to how Spinnaker handles multiple canary results. So if you're running 3 canaries, one in 3 different AWS regions, but you want your pipeline then to consume those results, how does Spinnaker think about the results from 3 different regions?
From one run, though, right? One.
Yeah. Yep. So that's what the result strategy refers to. Either take the lowest score and fail your pipeline based on the lowest score, or take the average of all those scores.
Cool. Thanks. Need to get your question.
When your pipeline failed in that case, do you have, can you tell us like what's the results that are parameters that are returned that go to the next stage for notification?
Yeah, so what is propagated into the calling pipeline is like the result, so a score, a reason, and some more classification information. So it'll say things like, it failed because this particular parameter was high. And I think there's more detail that can be surfaced that we haven't surfaced yet. But most of it is more like, besides the score, human readable information, and then the pass, fail, low, high, that kind of information. The idea is that I think in most cases, at some point, it becomes a human who makes a judgment based on that information. I doubt you would want to take the resulting score and do something based on that value automatically, because the thresholds are where you're deciding did it pass or did it fail. If it fails, I think then a human has to do something.
I want to be able to forward it to the application team to do the triage.
Yeah, it's surfaced into the, but so this kind of information, including the score, is in that result that's propagated into the parent pipeline and can be used in the notification messages with a simple expression.
And there will eventually be a report UI that you can click on it and drill down like we saw yesterday. That's not done yet, but that will eventually be there as well. So you can click that link and that should give them all the context.
Yeah, maybe the report is really good.
I think it probably wants like more custom notifications than just building expressions. So you can say send report as part of this notification. But we haven't done that. So last bit here, and this is also like a retrospective canary. In this case, 30-minute intervals, but we configured it with a sliding window. So it just looks back 30 minutes. And if you look at the times here, so they're each 30-minute durations instead of 30 and 60. And so, but the idea is you can sort of mix and match the different parameters based on data you've already collected or data you haven't collected yet, and you don't have to wait for all of that to be collected. Any questions about stage UI? I'll go back and then we'll sort of finish up the slides and we're kind of on the time mark. But questions or?
When's it going to be available?
So we're the primary, like there's some odds and ends we have to finish, but that's not what's really blocking us from open sourcing it now. It really is running it internally, primarily at Netflix, to gain the confidence that it does what we expect. I mean, it's like we're kind of at that point now that it's starting to do that, but that's really what blocks it. I hope soon. It's not a great answer, but that's a realistic answer. Yes.
Is there any kind of spec, I mean, in terms of adding support for other ways of fetching metrics? So say Graphite, I know it's not, maybe adding support for Graphite. Is there any kind of guidelines to maybe when it's open source or how to do that?
Yeah, absolutely. So we have one of our like internal bugs as a to-do is to write a guide for adding support for additional like telemetry services or metric stores. And Eric Weisblatt, who's giving a talk on monitoring metrics right after this, added support for Prometheus in like 2 days. And he wasn't working that whole time because I saw him at lunch and stuff. So it's not terribly hard. And my plan was to kind of quickly write up some notes. And I shared maybe a paragraph of pointers, and we sit next to each other. But it's pretty straightforward. We do need a guide. So the answer is when we open source it, there will absolutely be a guide. The idea is that it can't be that you just have to know who to ask or. Yes.
So you mentioned Prometheus. Is that kind of targeted for the?
It's in there already. So we have to, prove it out, learn more about it, come up with examples, all that. But it's in there. There's a sample Canary config. There's, somewhere. But it's all in there. So yeah, I mean, if you is that gonna work? Yeah. So there's a Kayenta Prometheus. It's not huge to add support for another service. I'd be surprised if it was 1,000 or 1,200 lines, and it's not 100%, but the plumbing works all the way through. So it's pretty solid. Swagger UI, everything's there. We use it all the time. We put a lot of effort into making sure we can run it locally, develop against it, and not have to stand up a bunch of stuff or need a monster of a machine to run it. So, all right. Want to come back up? I think. All right. So we noticed a lot of, especially in preparing for this, like copy and pasting from completed real-time Canary runs. So it seems like it would be cool to be able to just have a button that says, just capture this as a retrospective Canary, like copy everything over so I don't have to just copy and paste things over. Seems like it would save time. And then Michael pointed out, like, why do we need a pipeline to do that? And you don't really. So maybe even a more of an ad hoc Canary that sort of runs and you can check on the status. And then if you're happy, persist it as a pipeline config. And then things like I noticed we do a bunch of like adjusting the boundaries and the parameters to try to get it to sort of fail as quick as possible, or how soon can we gain confidence that we know which direction to go. So it feels like we can do more advanced things like that because we have the system that can be sort of dynamically interacted with, where we can change just the parameters without having to call the backing systems again. Feels like we can do some of those more sort of advanced things. Thanks. That's us. We're on the Slack channel a lot. Any questions we didn't get to, or no complaints? Chris?
What does Kayenta refer to?
Michael?
So a long time ago, a bunch of us sat in a room and tried to come up with something that had various characteristics. And one of the things I don't like are things that are named so similar to something else that if you search for them, you're going to find 20 things that are unrelated. And there's a coal mine in Arizona called Kayenta. And we figure canary in a coal mine. It fits. But there's also a town named Kayenta in Arizona, and apparently one in Utah. It's also a geological formation that is called Kayenta. And most importantly, it's the one that wasn't in the Urban Dictionary.
So before I forget, this is a big joint effort, obviously. So Dan from Google, Scott from Netflix, and obviously we're working with Chris from Netflix. So this is a big joint effort, but it's been fun. It's been cool. This is our plan for the open source Canary strategy for Spinnaker. As far as we're concerned, this is going to be the thing. Several of us are working full time to get this thing ready. So it's not a matter of us just not being sure. We're just not there yet. So.
And the plan is also that we will be using this internally to Netflix. This isn't something that we're going to open source and use part of. We've done that for some other projects you might be familiar with. The only thing that's going to be custom to Netflix are things querying that are internal things that we just haven't open sourced.
John.
So in the talk yesterday about the Netflix internal Canary stuff, how do you plan on migrating from that to Kayenta?
There are some technical challenges there. One of the things we do right now in the old system is that we have a filter-based system that, passive low, passive high. In the new system, we're going to be developing something that says this is an error metric, so it has certain characteristics. So comparing direct apples to apples is going to be a little challenging. So I believe the plan currently is going to be very much perception. Like we can run, since we can run both of these simultaneously. People can choose which one, the early adopters can choose which one is actually the threshold or both. And if the results are at least as equivalent from their viewpoint, which ones are good, because that's really the end goal is, are we providing good service?
So you're going to run Canary on 2 Canary systems?
You're going to be Canary and A/B testing, maybe, I think it would be. I don't know if it's Canary or A/B testing there. Ironically enough, we can Canary Kayenta. It's kind of nice. We could Canary the old system, so that's another reason. But that's the general plan to start out with. But eventually we will try to guess what their intent was on the ones, the other configs, and try to come up with the idea. I mean, we have a lot of heuristics. If it has the word error in it, it's probably an error value. It's probably latency. People name things pretty well, but if they don't, we can just contact them. Or hopefully, when we rolled over, we won't break anything. Hopefully, if we do break something, we break on the side of not letting something out that's bad.
Oh, I didn't answer Tomas's question. I just realized. So the same way we're synthesizing wait and run canary stages, we can synthesize deploy, destroy, or scale down stages, as well as like sort of commingled resize stages. So if you wanted to have a configuration that said, well, run this canary and also use it to control traffic distribution over time, you can drop in resize stages at the point each interval completes to adjust the baseline of canary groups. So should be simple.
Custom pipeline and everything based on the canary.
Templates or something. YAML, I don't know. But yeah, it should be straightforward to synthesize what we need. But yeah. Thanks. Appreciate it.